Okay, we're looking at this problem, and it asks us to find the volume of the solid generated by revolving the region bounded by the graphs of y equals cosecant x and y equals 2. Okay, so we need to look for the region bounded by the graphs of y equals cosecant x and y equals 2 about the x-axis. Now, they only want you to think about between 0 and pi for your graph. So, because remember the cosecant, it's like those it's a series of sort of U's and N shapes that are sandwiched in between its asymptotes. So you might want to use your calculator as a tool here to give you a sense of the graph. Make sure first that your mode is in radians, and then when you go to y equals, cosecant is the reciprocal function for the sine, so I did 1 over sine x, and then in y2 I put the 2. Now for my window, I just went from 0 to pi, and my y min and y max I just made about -3 to 3, because I knew there was going to be a horizontal line at y equals 2. And so here's the shape, and it's this region inside that's bounded, that's going to be revolved around the x-axis. So I'm going to take that shape and kind of work with that a little bit. So it's this region that I'm going to kind of see if I can, this region right in here that we're going to revolve. All right, so let's imagine what's going to happen is here you're going to have sort of a, oh sorry, doesn't look very good, let me see. So really you're going to have this whole thing is going to be revolved around the x-axis, and so this U shape of the cosecant, you can kind of imagine it coming through like this, and then you have this part right here. I don't know. And so this, here's a circle, and then here is a circle, but then this part's taken out. So it's kind of this strange looking shape that has a middle part taken out of it, and it has this outer. So it's actually, it's like a cylinder, but then what's cut out of it is not just another cylinder. It's got this sort of cosecant shape. It's sort of almost like a parabola as it's cut out. Okay, so what you're going to need to do is, you've got this outer circle, which is right here. You want to think about an outer circle and its radius, which will just be length 2. This is just going to have a radius of 2. And then the inner circle, and just because I'm running out, this looks kind of messy right here, I'm going to put it right here. This inner circle, its radius, the height of it is just cosecant x. Its radius is just cosecant x, from 0 to cosecant x. And so you remember, in order to get the volume, or the volume, you're going to use your formula, and it's going to be pi times the area of a single circle, and then you integrate that. And you're going to integrate that along the x-axis from here to here. Okay, so we need to figure out, where does y equals cosecant x, for what values of x is that equal to 2? So you may want to think of this as 1 over the sine of x, and you want to set that equal to 2. And then you can cross multiply here, and so this is going to be, and then divide. So this is really saying, when is the sine of x equal to 1/2? And so if you look on your unit circle, you should see that this is true. And I guess I can draw in a unit circle real quick for you. If you look on your unit circle, remember you're only looking at it from 0 to pi, and the sign is only positive in the first, well, in the first and the second quadrant from 0 to pi. So, oops. So right here, and then also right here, the sine value is 1/2. So this angle, if you look on your unit circle, is pi over 6, and this angle right here is 5 pi over 6. I didn't mean right there. The angle, it's actually this angle right here is 5 pi over 6. So those are going to be your limits of integration. So this is true when x equals pi over 6 and 5 pi over 6. Now, there's infinitely many places where the sine of x is equal to 1/2, but I have to stop because I'm going to run out of time, but also I'll pick this up in just a second.